Recording?
Yeah, you can go ahead.
Okay. So I pasted a link on the chat. So I want, say he's not able to hear. Can you guys hear me? Recording?
Yeah.
Can you guys hear me?
Go ahead.
Okay. So
Yes, sir.
I think there's a huge
I pasted
delay
a link on the chat.
Yeah, I think there's a huge lag, Rashekar.
Yeah, you can go ahead. Sorry, I mean, the YouTube live streaming was playing in the background.
Okay.
That's why you had.
That's why.
Yeah.
Okay,
Yeah.
that's fine. Not a problem.
Shouldn't be a problem now. Yeah, go ahead.
Okay, so now I posted a link. It's called katakauda.com. So Jagdish, Shiva, and Thirumal. So do you mind clicking that link for me, please? So let's do one thing. So who is available to share the screen? Hey, guys, there will be a lot of screen sharing going forward, okay? Because a lot of it will be hands-on, and I'm not quite sure how much of it you're actually doing by yourself. Okay, so Thirumal, can you share your screen, please?
Okay, sir. Okay, sir. Good morning.
Good morning. So what is your full name, Thirumala? That's your first name?
No, sir. P. Tirumala.
What is P?
Pandula Tirumala.
Yeah, okay, Tirumala. Okay, Tirumala. Okay, I don't know. Okay. Okay, Tirumala, if you don't mind sharing your screen, that'll be great. Okay, open that link that I gave you on another tab. On the chat, I posted a link.
Yeah, let me repost that link.
So what happened? The link disappeared.
No, I think Tirumala got disconnected and rejoined.
Okay,
so
then I can do that. I can post it. No problem.
Yeah, I just posted it.
It's katakoda.com. On another tab, just click on that link, Tirumala. Yeah. Login. And then log in with Google. So because you already signed in, you'll be automatically signed on.
Okay.
Yeah. Choose the account. Yeah, click on it. Yeah. This is what we call single sign on. So while this is happening, I would want everybody to try the same thing. So the rest of you two guys, tell me where you are on this. What happened? Error?
So,
Click on login again. Okay. 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 Yeah. You logged in. Okay. Come down. So logout is there, right? Okay. Come. And then you'll say learn and discover the latest technology and tools. The first stop. Okay. Yeah. Docker, runtime, containers, and builders. Click on it.
this one is.
Yeah. Click on it. Click on it. Start course. Yeah. Click on it. Start course. Come down. Okay. Now this is your what's the container start scenario.
Okay.
Okay. Now some gentleman or some company, as you know, is kind enough to prepare these tutorials, so you don't have to worry about installing and everything, right? Now click on start scenario. Yeah. So okay, now you can see that okay, containers are just normal Linux process with additional configuration applied. Launch the following Redis container so that we can see what is happening. Now you don't worry about what it means, but just click on that, you know, at the end of that statement, right? Docker space run, there's one arrow button. Yeah, click on it. Okay, click on it. Now it's running there. Okay, now don't do anything. Now what is it doing? So Docker, okay, I'll just briefly tell you before we get into it. Okay, what is Docker? Docker is a command line utility that helps you build, start, run containers basically. Okay, now when you see in the outside world, Docker also can mean a name of a company, it's a runtime engine for Docker and so all that. Okay, so what you're doing there is when you run the command, so Tirumala, just read the command please for me.
Doc. Which one, sir?
The command, whatever that you put there.
Docker.
No, I'm saying read the command.
This one is sir. The Docker
No.
container.
What did you put there?
Okay. Docker run. Docker space run.
Yeah, don't forget about space. Just say Docker run.
Docker
Okay, so
run.
why are these guys getting out and getting in? Is there any problem?
Yeah, maybe their network is not good.
Yeah. So read it please for me.
Docker run -d name equal to db redis :alpha.
Okay. Now what you are telling is Docker, you run this container, and I'm going to call it DB, and the container is from Redis, and it has got a subtag of Alpine. Now, what does this really mean? It's like, you know, you tell your brother, you know what, chicken biryani, Hyderabadi, okay? But how does he know? I mean, let's say your brother, you're telling, you know, chicken biryani Hyderabadi. What does it mean if you tell him like that? I mean, you said, I want chicken biryani Hyderabadi, okay? You're not telling him from where, okay, when, and all that stuff, right? So let's assume that you want, What does he do? What does he do? I mean, he'll run and get chicken from where? What do you think he'll do? Tirumala, tell me. Come on, Tirumala, I want you to speak up. Where is he going to get the chicken biryani from? Come on, see, I want you to talk. Where is he going to get his chicken biryani from? If you just tell him that.
Just he go to the
Hey, what is
restaurant.
these guys are swinging around, or what's the problem with both these guys?
Hey, Shiva and who else is missing? Jagdish, right?
They're going and coming out, it appears.
Maybe, I mean, Jagdish has some network problem.
Okay.
I think only Jagdish is.
See, this is very important topic because what I noticed is these guys are not looking at recordings or whatever. I'm not even sure. Okay, so Tirumala, tell me, where is he going to get it from?
He go to a restaurant and then he ordered.
But which restaurant he will go? They're like near your house. There are 10 of them. Normally, in such case, what happens is you both know where you like to get biryani from, and both of you implicitly agree on something, right?
Yes, sir.
That means probably you previously you got it from ABC biryani, okay, or Dalal biryani that you like, and then every time you get it from there. So when you tell him, hey, get biryani, then he will just go and get to the Dalal biryani place and he'll bring it, because you don't have to explicitly tell him, because there's an implicit agreement between you that get from Dalal biryani. Got it?
Yes, sir.
Okay. Now in this case, where does it fetch the Redis Alpine image from? No, that Redis Alpine is actually name of the image.
Okay.
Now, okay, now if you say first thing, what is it saying is unable to find image Redis Alpine locally. What does it mean? So what you're telling is, hey, Docker run DB and then Redis Alpine. So what Docker does is first it will find out if the image is available locally on your system. Okay.
Okay.
The first time that will see if it is there locally. If not, it will go and fetch it from Docker registry. Now, if you want to get it from somewhere else, okay, then you have to explicitly say, hey, get it from so and so registry. Okay. Now, Docker registry is kind of the default registry for a lot of these Docker containers. So if you go to the Docker registry, you'll pretty much get every image that you'll ever need. Okay. Now, so now you probably, we're not going to do much on this, but remember there are 6. Go back, go to left arrow and then go back to the, go back. Okay, leave, click on leave. Okay, now here there are 1, 2, and then if you look on, and then so what is a container? That's one scenario. And what's a container image? That's another scenario. And then 7 scenarios by OpenShift. Linux container internals 2.0 workshop. Okay, I want you guys next session, I want you guys to complete these exercises. Now you can do it 101 times, nobody will stop you. Okay, you don't understand. So next class, why I'm asking you to do it as well, next class we'll go through this step by step. Okay, I'm going to walk you through that. Now I want you to complete the 7 scenarios, and then what's a container and what's a container image. Got it, guys?
Okay, sir.
Okay, sir.
Now I'm going to share my screen. So hopefully you can see my screen share. So we'll get into theory aspect of it now. Okay.
Yeah.
Any question?
Join and
Okay. So long back I told you that you guys need this account: GitHub, Docker, Katacoda, Quick Labs. Okay. Okay. So Docker and containers, it's called disrupting the virtual machine. Now Docker is by far the most uh, famous container runtime. Okay. Now we will not you'll understand what it is, and but before that we'll understand what is container before we go much into it. Okay. Now you know virtualization, right? We talked about it. Okay. Now without virtualization, how what happens? Like you have a hardware, you have an operating system, and then on that you run the applications. This is how it was always been. And then the last class we have seen how to create a virtual machine, right? Hey, if you're not speaking, please mute. And I want you guys, whenever I ask a question, to immediately answer it. Okay, unmute and answer. Okay. Now we have the last class. We have
Sorry,
seen,
sir. Sorry, sir. I rejoined now. So my Zoom issue. That's why I
okay.
rejoined.
Now pay attention, guys. This is very important because without if you don't know containers, right, everything else is kind of useless. Okay. So you have physical host hardware, and you have virtual machine monitor. Sometimes we also call that as hypervisor. Okay. Now in our last session we saw how to create a virtual machine. So you have, remember, we created virtual machine. It's called VM0, VM1, and so on. And then it actually sits on some hypervisor, and we don't have access to it. But remember, that's how it is. Okay. Now one of the improvements that came along. So when you look at why containers, right? I mean, you remember two things. You understand that industry is trying to see overall. I mean, from between 10 years to now, your productivity has gone up, right? Our individual productivity. We are doing a lot of work on mobile devices, right? And our productivity has improved. Our machines are running faster. There's much higher availability of resources and so on. But one thing that industry is doing is, how do you maximize utilization of your resources? When you think of resources, primarily hardware, what that means is what? Uh, Storage and compute. Now we're not going to talk about networking, but let's stick to storage and compute. When you think of compute, it's CPU and RAM. Okay. So how do you improve it? So you have virtualization, and you want to improve on it, right? You want to the utilization of these devices, right? Come to become really high. I mean, you want a lot more utilization from it. Okay. So apart from that, virtual machines are fat. What does that mean? It requires its own OS, right? Now, when you have these machines with its own operating system, I mean, you could have like a Windows and the Linux machine, the same hypervisor. Okay, so virtual machines are fat because it requires its own OS, and because of that, there's a lot of overhead in terms of the hypervisor that emulates the hardware. Now, hypervisor will talk a different language to a Windows VM compared to a Linux machine. Okay, so there's a whole lot of multiple duplicate activity there. Even if you want to run an application, you need a full stack operating system. Okay. Maintenance. If you want to patch individual OS on the VM as needed, it's very difficult. Okay. Increased complexity when there are huge number of operating systems, the VMs that need patching. Okay. And you need to explicitly turn on virtualization at BIOS. Now, another thing you may all be familiar with is that the hardware chips that come out, right, from both from Intel and AMD, they have hardware virtualization already built in. Okay, so that's a huge improvement. So you should realize that there's a whole lot of hardware improvements that are happening. The intent is that you want to achieve a lot more with the same hardware devices. You got it right? Any questions? Any
Rama,
questions,
there
guys?
is some background noise from your side.
There's background noise.
Yeah.
Is it like
I
from a
mean,
fan?
it's not background noise, but maybe it is your mic sound. Gurr kind of.
Okay, how is it now? Is it different?
Yeah, it is much softer now.
Okay, much okay. This okay. Then there's something nonsense is happening on this guy. But I have a fan in the background. Is it troubling you?
Oh no, it's not the fan.
Okay. So any questions, guys? Any questions? See, I expect that you keep asking me questions. Okay. Now, one of the some of the market trends in virtualization. These days, pretty much every device is getting virtualized, right? There's compute. There is storage virtualization. Okay, we call it software-defined storage, and there's network virtualization. That itself is a huge topic in itself. We have virtual switches and routers, and network function virtualization. And then again, software-defined networking. That's another network virtualization. There's an article. So I'm going to post this PDF for you guys and send it to Rashik. Hey, Rashik, you can send it to them, right?
Yes, I can send it to them.
Okay. Yeah, I can read this article. Okay. Now, let's take a dig into containers. So this containers, to understand completely, right, you should get your hands dirty using it. Okay. Containers are lightweight, isolated operating system environments or processes running on a host. Okay. Containers are lightweight processes. So you guys are familiar with process, right? How do you find out what are the processes running on a system? What command do you use, guys? What command do you use? Tell me, what command do you use to find out what all the I want to know, what are all the processes running here? How do you know?
Guys, I mean, if you know,
You guys got to talk, man. See, this is not a question. Say, I don't know, because we're not going anywhere with this. How do you find out? Tell me one command on Windows. So on Windows, how do you do it? Kirmala?
Sir.
On Windows, how do you know what the processes are running? So let's say you are running some application, you don't find it anywhere, but you remember, okay, I know I started it. Now, how do you know whether it's really running or not? Okay, what about the rest of the folks? Guys, you can't be like this, man. You should know how to find the processor running, right?
Yes, sir.
How do you find out the processes that are running? Jagdish.
In Windows, we are checking go to computers and properties. I need to check that.
No, you don't get it on properties for sure. So what else property? Okay, what if you don't have those tools from the command line? How do you go? What about on Linux? What about Shiv Kumar?
Sir,
How do you find out? So anyway, so on Linux, there's something called PS command. Okay, PS minus FE or AUX. In fact, you'll run some of these commands in the tutorial that is okay. PS minus FE will actually give you that list. Okay, now, but because there is huge list, how do I filter it? I'm piping it to grep. What is grep command? What does this do? Tell me, guys, what does this command do? Tell me. What does it do? Guys, come on! I want you to tell me.
It searches a file.
Searches a file. What file?
I mean, like
What about you, Jagdish? Firma, can you answer? Okay, so the first command is PS minus FE. What does it do? That we saw that before. So it will actually list of all the processes that are running, right?
processor. Yes.
And what is that symbol following that command? That line, small line. What is that? What do you call that actually?
Is it a iPhone, sir? Or
No, I mean you can see clearly, right? What is it? You have. You want me to expand it?
it is
What keystroke is that?
Yes.
Control plus plus. Let me. Okay, what is it? Okay. What is it? What is this guy do? What does it do? This thing. What exactly is that symbol? Tell me what is that symbol character called? That's called a pipe. So pipe is a device where you write from one end and read from the other, or vice versa. Got it? Pipe. Okay.
okay, sir. Okay, sir.
Now, what is that grep? What is that grep zoom? What does it do, guys?
Guys, do you remember there was some material that was shared by Jagdish with all the Linux commands, and I have discussed that in one of the meetings, one of the previous sessions.
Okay, so okay,
Yes, sir.
so what this command is doing is, so it's doing a PS minus FE, and it's taking that output and then sending it as a pipe, as an input to the grep zoom. Actually, other way around. Okay, so PS minus FE is one output, and then I'm processing it through grep zoom. So grep is actually a search and find utility. So it's like if you're saying grep for zoom, you'll say, okay, wherever it's case sensitive here, you can use that -I option. Okay, ignore case. And so, get me all these commands, and then in that search for wherever you find zoom. Okay. So this is a process. This is one process. This is got process ID. This is a process ID. This is a process ID. Now there are two numbers, right? This is the process ID and this is the process ID of the parent that started it. So this guy, so first this guy is the root, process PID 1, and this guy is a child of this guy, and then this guy is a child of this guy. You can see these numbers here, right? And so on and so forth. So okay, so zoom will start, and then it'll throw up some windows and all that stuff, right? So that's all this thing. Okay. Now PS my pipe it to more. What is that? What does it do? What does this do? PS pipe it to more.
Searching text, sir. Text from input.
So when there's a huge output, right, it'll actually send it to the more command, and more command will display it page by page. Okay, so these are all the processes. Now you can look at it. So root means what? The process is owned by the root. This is a super user. Okay, this is a processor ID. Okay, got it?
Yes, sir.
Okay, now let me do this. So what I want to do is, if I want to -FE type it to grep for Rama K, it will actually list me all the process where Rama K is there. So in technically that I own the Rama K user, not the root user. So this is my user, and this is the processor ID. And then what does it do? It is running Chrome. So now I have multiple Chrome tabs. So it's showing so many of opt Google Chrome commands. Okay, so this is a command that it actually ran. Okay, now there are better ways of looking at getting the list of all the processes that are owned by user, but I think I'm telling a simplest way. Okay, now some of these you'll be using in the tutorial. Okay, let's get back to the okay. So okay, now it's so containers are a lightweight isolated operating system components. Now what we saw, the processes, right, they're not containers. Now what distinguishes between a container and a process is that container is very self-contained. It is very self-contained. It has got strong isolation. Now process also has got a kind of an isolation, but if you become root, then all of so anybody can access, so all the root users can access the process space. But that's not the case with containers. In fact, I mean, for the most part, the way containers run, just because you're the root of the machine, you can't access containers. Okay, so they don't need additional hardware capabilities such as Intel, VT, and so on. They don't need emulated BIOS or completely virtualized hardware. So somebody asks you what are containers? They are lightweight processes with strong isolation. Okay. Now, any question, guys? You should ask questions.
In containers, we have processor. Everything is there, right?
Okay. What do you mean?
Sir, here, yeah. Processor ID.
Yeah, container ID. Actually, when you run,
Yeah, content.
see, you have a container ID, but we will show
Okay,
you.
sir.
We'll see.
Okay, sir.
Any more questions? Okay, so Linux containers and operating system level virtualization technology. Now, you remember we had this hypervisor. We talked about there's operating system and then hypervisor on top of that. Now, some of the features of the hypervisors are now merging into the Linux operating system. So because of that, now it's a lot more easier to run containers without any hypervisor. Okay.
Yes, sir.
Unlike virtual machines, containers do not run dedicated guest operating systems. They share the host operating system kernel and make use of the guest operating system libraries for providing the required OS capabilities. Now here is where it differentiates with virtual machines. Virtual machines have their own operating system, right? Containers do not have their own operating system. Okay. When you say Linux container, it means that it will run on Linux. That's all it means. Okay. Got it?
Yes, sir.
Okay. Containers run on a host operating system that provide allocation and assignment of resources such as CPU, memory, block IO, network bandwidth, and these do not interfere with the rest of the system's resources or process. Okay. So think about Linux. So container, it's a process and then provides isolation. But how is it possible to get the kind of isolation like a VM and still be lightweight? Okay. So the question that you should probably ask is, how is it possible to get the kind of isolation like a VM and still be lightweight? So if you compare virtual machine, right? Container is very much similar to that, but it runs very fast, small memory print. Now, on a machine, right, you may host like 4 or 5 virtual machines, but containers you may host 100 of them. Okay, and all these 100 containers are isolated, so they don't know the existence of other containers. Okay.
Yes, sir.
Yeah. Do you have any question?
Sir. Hello, sir.
Yeah.
Sir, Linux. Sorry. Containers are working only on Linux, sir.
Okay, containers are also available on Windows.
Okay, sir.
But
Okay.
that's a Microsoft has done it. But containers first came on Linux and they got standardized. In fact, Windows is a bit behind. So a lot of containers. I mean, there's a whole lot of. When you think of cloud native and all that, we can talk about it. But Windows containers are very far behind. In fact, I've had no experience with Windows containers. Okay, but
Okay.
when you think of containers, it inevitably means Linux. And Linux containers are almost like 5 to 7 years ahead of Windows containers. Okay. Now here is a picture that actually compares VMs and containers. Okay. Now you have virtual machines, you have guest operating system, and then you have hypervisor. Okay. On the right side, you'll see containers. Okay. Now there is a host operating system, Linux, for example, and then you have on top of it, you have the Docker engine. Okay. Docker engine is what? It's called a runtime, container runtime. Now, remember, Docker has so many definitions. Docker is the name of a company, it's the name of a registry, it's a container runtime, it's also a command utility to run Docker and build images and everything. Right? Now, there are other container runtimes called container run C and all that stuff. Okay, we'll talk about it later. But
Docker is, Docker was the first company to open source and then build containers and so on. It became very popular, but of late, there are other container engines, and Docker is kind of dwindling. It's kind of reducing, but it's still the standard. Okay. So when people say containers, the first name that will come to your mind is Docker. Okay. So here is a better example of what Docker containers versus virtual machine. Your application A, so you can see the isolation, right? App A will not interfere with app B. Okay. And in fact, app A will not know the existence of app B. Okay. Now, here is a chart that compares VMs and containers. Now, our container discussion will go on. It will the next session also, because unless you understand them fully well, you're not going to go forward. I mean, I can keep talking about, because the next big step would be Kubernetes, and that it will change the whole landscape. So on the virtual machine, you have each virtual machine running its own operating system, right? But in case of Docker container, what happens? All containers share the same host OS. Host OS can be different from the guest OS. Yeah, it is. You have hypervisor, type 1, type 2. You don't have to talk about those. But host OS and the container OS has to be on the same Linux kernel. So which means you have a Linux, then you can run Linux containers, but you can't run like a Windows container on Linux. Okay. VMs are always running. Containers stop when the command it is started with completes. So what does that mean? Remember, the reason why we have containers is, do this job and get out. And that makes sense when these containers are lightweight, and then they take only like a couple of seconds to start and then to stop. Unlike a virtual machine. Virtual machine, it takes almost like 4 to 5 minutes or even some 10 minutes to come up fully, right? So virtual machine takes startup time is in minutes. But in kind of Docker, the startup time is in sometimes milliseconds or seconds. VM snapshots are used sparingly. Images are built incrementally on top of another like layers. Now, when you look into the tutorial, right? When you do the tutorial, you will actually understand how images are built. Okay, incrementally on top of another layer. Okay, you can run multiple VMs on a laptop, for example. Okay, you can run many Docker containers on a laptop. Okay, fully isolated and hence more secure. Okay, Docker containers have process level isolation and hence a bit less secure. Now, but that problem is being solved now. But right now, VM versus containers, yeah, containers are very, very secure. Okay. Again, so similarities is like virtual machine has got its own root file system, and this guy also has got his own root file system, different from the kernel. And again, the similarities, right? So in a process, in a virtual machine, right? Your typical process in a virtual machine, right? It doesn't have anything like an IP address or network adapters. But containers, it has got its own IP address and network adapters. Okay. Now, how did containers evolve? So it kind of evolved a long period of time. It started with chroot and so what is chroot? It's a system call that changes the root directory for the current running process and its children, restricting access to outside files. A way to isolate a process from the rest of the system. Okay.
Then in 2006 came a big change. The emergence of control groups, originally implemented by Google for limiting accounting and isolating resource usage, CPU, memory, disk, I/O, and all that stuff. Okay. In 2007, control groups became part of Linux kernel. In 2008, you got this LXC, which is a Linux containers combining control groups and kernel namespaces. Okay. In 2013, Docker announces Linux container management called Docker. Now, we'll not talk about control groups. It's fairly complicated topic. But if you ask, what are control groups? It's a mechanism that is implemented to restrict and isolate resource usage, CPU, memory, disk, and all that stuff. Now, when a container starts up, right, you can actually tell the container, no, don't you use only 512 MB RAM, don't use more than 30 CPU cycles, and so on. Now, that thing, right, it's maintained by the control group. Okay. Now, something similar doesn't exist with the real process, typical process that we know on the Linux. Any questions, guys? Okay.
No, sir.
Okay, names. We'll not talk about namespace. It's fairly complicated, so I'm going to spare you that. Okay. Now, some analogies about containers. Containers is also about standardization. Do you guys recognize this ship, man?
Yes, sir. Yes, sir.
What is it?
Here, like so many containers are there, like physical.
No, but name of the ship. Now, forget about the containers part. Now, name of the ship, Evergreen and Evergiven. What is it? Have you heard about it anywhere?
Ever given.
Yeah. Do you remember it?
No, sir.
So this picture, I mean, these slides I prepared in 2017 or 2018. Okay. So this slides, right, I prepared like 2-3 years back. Now, 3 months back, if you remember, a container ship got stuck in Suez Canal. Do you remember that? Three months back, a ship got stuck in the Suez Canal, and the whole trading route kind of stopped. So for 1 month, ships could not pass through. So anyway, this is the same ship. So interesting thing is this picture I have been using for the last 2-3 years. Okay, so on top of the ship you have these containers. What is the unique thing about these containers? What's so special? All containers are the same size, right? Guys, speak up.
Yes, sir. Yes, sir.
So what are the advantages of the containers being the same size?
Same size.
Guys, speak up. What is the advantage?
Yeah, easy to carry, and at the same time, the same we are using the same traveler also.
No, what do you mean? Say easy to. What do you mean easy to carry? What if the container is half the size? Some of them are half the size and some are different size. What happens? I mean, give one word answer. What is the key advantage of same size, same weight, and all that stuff? It's called standardization, right?
Yeah. Yes, yes.
Yes. So when you go and buy a T-shirt, right? You know your size.
Okay, 38. So all 38 sizes are same, right? So when you buy jeans, I mean, when I go, how do I buy my jeans, man? I go to the store and keep trying everything that and see which one fits. What's the logic? When I go to,
Before we need to check size.
yeah, so I go and my size is 34-29. So I'll go and see, pick up jeans 34-29, and then bring it home, right? I don't have to try it, right? What's
Yes.
the guarantee that it will fit? The guarantee is the size that is marked. Okay,
Yes. Yes.
assuming that it comes with some level of trust. Okay, okay. Now, so why I'm bringing this ocean ship example? Because eventually a lot of the terminology that you talk about will be related to oceans and ships and all that stuff. When you move from containers to Kubernetes is a term that is associated with the shipping industry. And then you talk about Helm, again, shipping industry. Docker, what does it mean, Docker? I mean ship will dock, right? The name Docker came because what does the ship do? It is docking at a port, right? That's an example. Okay, so let's pick up about analogy about containers. So one of the benefits is some guy decided that man, we have to standardize all these. Okay, standardization on shape, size, volume, weight. Okay, so the advantage of standardization is economies of scale, because a ship is designed to handle X number of containers. My ship can carry 30,000 containers. So what is there in that? The captain doesn't have to care. Okay. Now, what are the benefits of standardization? This is what it is. A ship docks it on the port, and the container is kind of lifted up and then put on the train. It goes somewhere, and from the train, it put on a truck. Right? Now, the same analogy is used in Docker too, because once you build a container image, right, it should run on any Linux. Okay. So containers come out of container images. Okay. A container image in its simplest definition is a file which is pulled on from a registry server and used locally as a mount point when starting containers. Each container engine has its own format: LXD, RKT, and Docker. Okay. Today, almost all major tools and engines have moved to a format defined by Open Container Initiative. This image format defines the layers and metadata. What's metadata? I mean, it's nothing to do with Linux, but metadata is a generic term.
It's a configuration files.
No. But guys, see, give me at a very high level answer. What do you mean by configuration file?
Yeah, actually, some
What does
process.
the word meta means? Forget about metadata. Tell me what meta means. Let's talk English, guys.
Yeah.
What? I mean, they're not just calling meta for without a reason, right? They're just calling meta for a reason.
Yes. Yes.
What? So meta means something over another. Okay. Metadata is what? Some data about
A set of
data.
document.
So what's the metadata about your operating system? Tell me. Okay, what is your metadata? Tell me. Guys, come on.
Metadata means a set of data, sir. Like,
What, a database is a metadata then? No, there's a difference between data. Why do we call it metadata? They can't call it just data.
Mm,
So metadata is data about data. So tell me what's the metadata about your laptop?
Mm.
No. Tell me the okay. What's the metadata about guys? Come on. I mean, you cannot do this. What's your metadata? What somebody asks you? What is your metadata? How do you say? What's Jagdish Kumar's metadata? What do you say?
is
Who's speaking? Jagdish, is it?
yes, sir.
Oh, Jagdish, tell me what is your metadata?
Like I mean, meta is a it's a
No,
configuration.
no, tell me your metadata about you. See, metadata about Jagdish Kumar,
Char-
his name, his age, his height,
character.
weight, what did he study, what is date of birth, what are his hobbies, what is qualification, where is he working, is he married or
Okay.
not, how many children he has. That is the data about you, right?
Yes, sir.
It is Jagdish Kumar's metadata. Now, what's the metadata of your computer? So, Tirumala, what's the metadata of your computer, your laptop?
I think
Laptop
hardware
OS
properties, sir.
processor.
Properties of hardware and
Tell me, don't give me all that. Start with the basics and then drill down. The way I told Jagdish Kumar's metadata.
Laptop model, version, processor, OS.
What else? Okay, so every laptop has got its model number,
Yes.
serial
yes,
number.
sir.
We'll start there. Okay,
Yeah.
model number, serial number, and what else? Operating system, the version of the operating system, how much disk space it has, how much RAM it has got. You don't have to go into detail as saying it has got MMC, this kind of RAM, and all that. I mean, that's all the data, but let's get very higher. Metadata. Okay, it's more like properties. Okay, price. That's all. Metadata. Okay, guys.
Got it.
Yes, sir.
Okay, sir.
So start giving answers at a very simple level before you dig in, because otherwise it looks very vague. Okay.
Yeah, Rama.
Yeah.
Yeah, I think we have introduced some complex topics today. I'm not sure like how much more you would like to cover in this session. So what I was thinking is, let us ask these guys to go back and do the exercise that you
Yeah.
gave.
Yeah. Actually, what I'm thinking is, because all these topics will be covered in the exercise, and I want them to know a bit about it before we jump into it. So what I'll do is we'll wrap off this slide, and then we'll look at the exercise. Okay.
Okay, sure.
Now, what I will do in the next 15-20 minutes, we'll walk through an exercise. Okay, I'll walk through, and then you guys observe, and then these things you're going to do it twice or thrice in the next 1 week. See, this ride is going to be challenging one for you. Okay, it's fairly complicated topic even for the experience, so I want you to take this slow step. See, when what do you say, the kind of tools that are available right now, right, they were never available before, because when I started learning Docker, I had to install it myself, and I spent hours together wasting my time doing it. Okay, and there was still confusion. But imagine if somebody has done it for you and make learning so easy. I mean, what more can you ask for, right? Okay, so what we'll do is we'll do the simplest exercises. Okay, now what's a container and what's a container image? Let's do these scenarios. Okay, because we did some of it partly. You can see my screen, right?
It's
Okay, now this company, whatever it is, it's actually throwing out a container for us here. Okay. Now start. Okay. Now this one has got 6 steps. What a container? Containers are just normal Unix process with additional configuration applied. Okay. Launch the following Redis container so we can see what is happening under the covers. What is Redis? Anybody?
It's a name.
Yeah.
Name of the Docker.
What? Actually, Redis is actually a database. It's a NoSQL database, and it has gotten very popular. So these days, Redis is everywhere. So okay. So what I'm doing is Docker. So okay, Docker. So when you say Docker, you see plenty of commands, right? When you say Docker, it is Docker command. -d debug. Okay. Post iv dash version. Okay. Let's do Docker dash v. What does it say? So Docker version is 17 point whatever that is. Okay. It shows a lot of commands. Okay. Now, okay, Docker ps. What does Docker ps do? What does Docker ps do? Come on, guys. We didn't talk about it, but I threw enough hints. We looked at the ps command. What does the ps command do? Guys, right now you should be smart enough to interpolate.
PS is nothing but how many processors are running on computers?
Not how many processes, the list of all the processes. So here, what does it do?
Oh,
PS
now
will give the list of all the containers that are running. Okay. Now let's start here. So you can actually type this command as is here, or you can press this command. Okay. But don't be lazy. Okay. Don't do that. I mean, if an experienced guy doing it is fine, but you simply don't do this. Press here and then keep clicking this. Okay. So run the everything. Make mistakes. Typing mistakes. That's fine. Okay. Docker run -d. Okay. Dash name is equal to. Let's give a different name. Test dash db. Okay. Redis Alpine. Okay. Now. So this is the command, right? Fine. Hey, you can see my screen, right?
Yes.
Okay. Now, if you look at it, right, it's first it's saying is that Redis Alpine available here locally? Locally means on this machine. Actually, we'll see what operating system is it. Linux based Xenial. Okay, Ubuntu machine. This is okay. Now, okay, so Docker run. Okay. You remember Docker? Where is Docker running? In fact, this is a Linux operating system, and on top of that, Docker is running. Okay, Docker is a runtime. Okay, that will manage all the containers. Now, unable to find image, Redis Alpine locally. So what it does? So if it doesn't find locally, where does it get from? We talked about this in detail. The biryani analogy. Guys, come on. It doesn't find locally. Where does it get from?
PS -FP grep zoom.
No. Okay, guys, you completely irrelevant stuff. What is it? So remember the biryani. Okay, explain to me the biryani logic we underwent. The biryani story. Did you guys listen to the biryani story?
No, sir.
So tell me,
Yes.
what's her name? Tirumala.
Yes, sir.
Tell me, we discussed that biryani story, right? Now tell me, unable to find, then it should throw an error, right?
Redis.
But what is it
Yes.
doing? It still got it from somewhere. What happened? Where is it getting from?
Mm.
Guys, remember I said Docker registry. Okay. If you type Docker registry, what is Docker registry? It's a hub. It's like you guys live in Mahatma Gandhi. You guys live in Hyderabad, right?
It's
Yes, sir.
Right. So if you go to Mahatma Gandhi bus station, you get buses to every corner of Telangana and Andhra, right?
Yes.
So
Yes, sir.
you have to go to some corner, okay? And if you go to Mahatma Gandhi bus station, you will get bus to anywhere, okay? Think of that as a registry. Registry means what? Anything you want, you go and get it from there. Like think about it as an example, supermarket, okay? So if here you will actually find uh, pretty much every kind of image that you need, okay? So Docker Hub, it's called a Docker Hub, repositories, service accounts, okay? Now you can search for Docker Hub and then see what all images you have, okay? uh, how do you search the Docker Hub? Let's go and search the Docker Hub repositories, okay? So anyway, so this it's there somewhere, okay? This is the Docker Hub or Docker registry. That's where. So why this is important is because when you're working in a company, your company may set up its own registry, okay, locally. Got it? Okay. Now what is this? So it's not finding locally. So where does it go? Docker registry. So it will pull the image from the Docker registry. So what is this pull 1 2 3? So it's first pulling Alpine, which is a kind of a Linux container, and then it's pulling all the libraries on top of that. It's built on layers. Okay. Now every image has got a Docker file. Okay, you'll see that later, and then it has got the list of all the images. It has got dias, which is like the signature. Okay, and status downloaded newer or so it did. So what if I do Docker images? So remember, it downloaded this image, okay, locally. That's why when you say Docker images, this is there locally, okay? We'll kind of play with these images later, but let's go ahead, okay? Now when you say Docker run, right? So what does it mean? Let's Docker PS, okay? So the container is running, okay, which is known by container ID, okay, and name is what it is, okay. So it is binding to some particular port 67. We'll get into that later, okay. Now ps minus ax grep for ready server. Now when you started Docker, right? So what is this 1197? So the root is, this is the Docker 1097 is the Docker daemons process ID. Okay.
Okay, sir.
PID, process ID. Every process has got a process ID. Okay. Started by the root. Okay. Okay. No, sorry, this is not the Docker ID. So this is a command. Okay. I thought it was a Docker ID. Okay. So this is your ready server. Okay. And this is the
Process parent.
yeah, so this is process ID, this is a process ID, and this is process ID of the parent. Okay, the ready server. So 1119 is actually the Docker runtimes ID. Okay, we'll find that out. Okay, so we do ps minus fe pipe it to grep for Docker. Okay, so you can see this, right? What is this? 999. Okay, so where is that? Where is 1119? How did this come here? You're not using grep anywhere, right? How is it showing here? Okay, I'll figure that out later. But yeah, we can come back to it later. So that's a process ID. Okay, where is it? This is a process ID for Redis server, right? It's 999. Okay. Now Docker can help us identify information of the process, including the process ID, PPID, and via Docker top DB. Okay, go ahead. Here it is. Docker top DB. So where does it give error now? Tell me. What should I change? What should I change? So I keep changing commands so that when there's error, right? So what is it? It says Docker top DB. What is the DB there?
Is it database?
Yeah, but what database? No, what exactly is it? What if I call it PQR? Docker top PQR. What does it mean? I mean, see, look at the previous commands that we gave. Where is DB showing up? Guys, this is not coming out of the blue. So what is this in the first command that we gave? Look at that first command and tell me. In the first command, what did we run? So we gave a name to the
Redis.
container that we are running. So what's the name of our container? It's not DB, it's test-DB. Remember, we changed it. Look at here. I'm underlining it.
Okay.
So what should the command be now here?
Docker term.
Docker top what? Guys, this is not from Linux. I'm using just common sense to relate. There's nothing, there's no technology stuff here. What name did we give here? So what name did you give here? See, if I give some textbook to Jagdish Kumar and then go and ask Shiv Kumar, hey, give me the textbook, what happens?
We require name of the textbook.
No, but let's say I gave a textbook to Jagdish and nobody else knows. Now I go to Shiv Kumar, hey, give me the textbook. What would Shiv Kumar say?
He's saying doesn't have the textbook.
Yeah, so how do I fix the problem? So what would Shiv Kumar say? Response is, hey, what the hell are you talking about? So how should I fix?
So go to Jagdish Kumar and take that.
Yes. Okay. So
Yeah.
go to Jagdish Kumar and ask for a textbook, right?
Yes.
So now tell me what command should I type here?
Name BDB Redis.
No. Okay. Docker.
Redis AL pen. Yeah, Docker.
Top.
Test DB.
Docker top and the name of the container.
Yes.
What's the name of the container? Guys, I want to do this like 3-4 times because next class I'm going to quiz you everything in detail. Okay.
Okay, sir.
Because so don't do this click. Okay. Okay. Docker. What's the name of our container, guys? We have seen this here. Go look at the previous commands and then check the output of each of the previous commands. The answer is there, right there. All you have to do is you have to use your common sense and then figure it out. What's the name of our container? when we ran this container, what was the Docker run command we ran before? When we did Docker PS, what does it Docker PS give us? Hmm?
Test DB.
Test DB, yes. So that is the name of the container we gave,
Yes, sir.
right? Where is it
Yes, sir.
visible? When you did Docker PS, it says container ID is this, image is this, command is this. We created
Yes.
5 minutes back, status of port names, right?
Yes.
This is what I want. Okay.
Okay.
Okay. Now, so it's giving all the information about our container. Okay. The container process ID is this one. Okay. Sorry, no, not this one. This is user ID. Sorry, I'm got confused. This is user ID. And then this is PID. This is process ID for the container. It is 1119.
Okay, sir.
And what is PPID?
Processor parent ID.
Yes. Who is the parent?
Parent. One.
Docker container runtime is the parent. Always for Docker runtime, or here in this case, it's called container D.
Container D. Okay.
That is the parent always, remember. So Docker container D, so some people call it Docker daemon. Okay, that's a parent ID. Okay.
Okay, sir.
And what is this start time is like, it shows some start time, right?
Yes.
It shows some start time, and then and what I don't understand what this one says, but yeah, but you got the thing. Okay. Now use ps minus ix grep for parent period to find the parent process. Okay, likely to be container daemon. Okay, now what do you type? Now this one I want you to answer this question. Okay, ps aux. Now remember we did ps minus fe. The other alternate is aux2. Okay, grep. Now what do you type here? Now look at this. What is PPID, and then what is use PS PPID to find the parent process likely to be connected? Tell me what is this? Guys, I'm not asking you right from the out of the sky, right? The answer is there staring into your face. Now, I want a quick answer. Read the statement. So what should I type here? Tirumala?
PID, PPD.
What? So here, when it says in the quotes, left arrow, right arrow in between PPID, right? What does it really mean? What is it this quote for? What is it? Why is he putting these arrows here? Guys, I don't know what you're thinking. Read it. Read this, what it says here. Nothing. It takes 2 minutes for you to read this and then answer. Because the point is, if you guys don't set your thinking right, we're not going to go anywhere. What should I type?
PPID, sir.
PID, sir. 1104.
Yeah. So why does it take so much time for you guys to answer that? 1104, right?
Yes, yes, sir.
Yeah. So this is same as the one that we got here. Remember Docker container D? So that's what it is. Okay. So now you see the parent process for container is the Docker daemon, container daemon. Here you see some people call it Docker daemon or container daemon, whatever it is. Okay, they're all the same. Okay.
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 Okay, sir.
Okay, I think what we'll do is I'm going to stop here. And I think this is kind of overwhelming for you, but tomorrow, next week, right? I'm going to go through this again and then answer the questions, because maybe you guys need little more of brainstorming. So what I will tell you is go ahead and do a lot of reading. Container. What is container? What is, so all reading. Don't bother about doing this assignment. Okay. Read these containers, because you should be very reasonably thorough with that. Okay. Read it,
Okay.
again read it, again read it. Because next time when we cover this, right, you'll get reasonably whatever you learned. Okay. It will help. We can bridge the missing things and so on.
Okay, sir.
You got it?
Yeah.
So, see, this is a challenging one. But guys, see, a lot of it you have to use common sense, analogy, and then move on. I mean, if you whatever I'm telling you, it's staring on the screen, you guys are not answering. Okay, you guys have to think. This will only get harder and harder. But if you want to go and succeed in outside, right, then you guys should know this stuff.
Yes, sir.
See, imagine some guys have taken the effort and made this learning so easy for you. It can't get any easier, man. Somebody's peeling the banana and putting it in your mouth. All you need to do is take the bite. You don't have to go out and then buy bananas or grow your banana tree, nothing. Because, see, when I started learning Dockers and containers, I mean, we didn't have this kind of tutorials. Now, here you'll see that, because I was kind of grappling with, technical issues with reference to installation, configuration, why this thing is not failing. They have cleaned up all it for you. Okay. Now that makes learning it so easy. Now, once you get solid on this, right, you go and run it on your machine, and then learning becomes so much faster. Okay. So what you do is, what's the assignment I said you guys are going to do next week for next week? Read, read, read. Now, you don't have to buy any book. Google for it. What's a container? What's a Linux container? Why containers? Why should I use even containers? Why do I care? Okay. Pick up
Okay, sir.
whatever interests you. They're humongous resources. Start with docker.com. Okay. And Docker is a tutorial. Learn everything. And forget about this katakoda exercise, because that will be too challenging. And unless you understand it, I don't want you to do it, because you'll say I've done it, but it's no use. So you got it, guys?
Yes, sir.
Okay.
Yeah. Yes, sir.
Okay. So let's wrap up for today then. So you know what to do, right?
Yes, sir.
Okay. So Rajshekhar, you want to give any? And one other thing, right? You don't have to be ashamed of anything if you don't know, but you should ask me. If you don't ask me, the implicit assumption is that you guys know your stuff. So I'm going to keep grilling you more. So after two classes, right, there'll be a quiz. So you guys had to be prepared for it. Okay. So that's why I do a lot of reading, containers, and then whatever gaps that you have, I'll fix it for you. And then you should be flying. Okay. So
Yeah.
that's guys. So Rashik,
Okay, sir.
Yeah. Thank you, Rama. So guys, I know it is like getting, technical more and more, right? So it's gonna be like this going forward. కొంచెం మన పాత రికార్డింగ్స్ కూడా ఒకసారి అన్ని చూసుకోండి. ఇది కూడా యూట్యూబ్ రికార్డింగ్ లింక్ ఇప్పుడు నేను ఆ వాట్సాప్ గ్రూప్ లో షేర్ చేస్తాను. సో అది ఒకసారి మళ్ళీ రివిజన్ చేసుకొని ప్రాక్టీస్ చేయండి. ఓకేనా?
yeah.
Okay.
Actually,
Okay.
you don't practice, because what happens is, right, they will just keep clicking, and then without understanding, So practice will start next week, but read material. Okay. I'm not going to give you resources because humongous amount of resources are available on the web. Okay. But what I want you to do is do some research on your own without I telling you to go and look in this website. Okay.
Okay, sir.
Spoon feeding. Okay. Okay, guys. I think we can wrap up.
Okay, sir.
Yeah.
Thank you.
So, yeah. So I'm going to stop this thing. All right, guys. So let's talk next week's session. And in the meantime, try to familiarize yourself with all the topics, and then get ready for next week.
Okay, sir. Thank you.
Okay, guys. Chalo then. Enjoy your
All
day.
right.
Bye.
Yeah.
Thank you. Thank you.
Thanks, Rama. Thank